This is the solution to WEX 421. Okay, so we're given a function. We are said that we can assume that the inverse, compositional inverse exists, so we don't need to worry about its existence, but we need to find it. Alright, so for part A, I'll start out by writing y is all that business, so 13x plus 14 over 20x plus 18. And we want to solve for x. So the problem is that we have x's in numerator and denominator. We've got to fix that. So I'll move this, I'll multiply both sides by the denominator of the right hand side, so that we get y multiplied by 20x plus 18 is equal to 13x plus 14. So now I'll multiply out the left-hand side. So 20xy, 20xy, then plus 18y is equal to 13x plus 14. Now we want to solve for x, so I need to get all of the terms which have x on one side and all those without on the other side. Okay, we want to solve for x. So this one already has x, so it can stay. I'm going to get this one over here, so minus 13x plus 18y is equal to 14. So that's, you know, that's just moving that one over there. So now this one doesn't have an x, so I'm going to move it over there. So 20xy minus 13x is negative 18y plus 14. That's just moving this one over here like that. So now there's no x's over here, and every one of these terms has an x. So now I'm going to factor x out of that to get 20 multiplied by y minus 13, and I've factored out x on the right. So I can check, because if I was to distribute that back, I'd have that. Good. So negative 18y plus 14. So now I can divide by that term in parentheses to get negative 18y plus 14 over 20y minus 13. And now we can swap the x's and the y's. So y is negative 18x, negative 18x plus 14 over 20x minus 13. And so our claim, is that supposing that we carried out that computation correctly, the inverse, h inverse of x, is that. So negative 18 x plus 14 over 20x minus 13. Okay, so that's part A. So now to solve part B, we need to show, we need to compose h and h inverse in both orders. Okay, so then for part B, so then I'll do h inverse composed with h, evaluate at x. This will be h inverse evaluated at h of x. So this will be negative 18 slot, and then plus 14 divide by 20 slot minus 13, and the thing that goes in there is h of x in both cases, so h of x, h of x. All right. Okay, so continuing that, that will be negative 18. And then in this slot, I need to write what h of x is, so that'd be 13x plus 14. Over 20x plus 18. Then this will be, so that's h of x, and then plus 14. Okay, so now over 20 multiplied by, again, the same thing, so 13x plus 14 over 20x plus 18, like so, and then minus 13. All right, so now what happens next is like a circus of algebra. So you've kind of got to have a good strategy. So let's see if I can think it through here. Okay, so for the moment, what we need to do is we need to solve sort of two different, work on two different parts of the problem independently. So what we want to do is we want to convert the numerator into just a fraction. So we want to find a common denominator just in the numerator, and then we want to convert the denominator into a single fraction, so that it's just a single fraction in the denominator. All right. So that is to say, we're going to work on that by itself, and we're going to work on that by itself. And the top and the bottom are not going to interact, at least for a little bit. All right. So I'll multiply the 18 into the numerator. So then that will look like, so negative 18 times 13 is negative 234 x, and then negative 18 times 14 minus 252. Okay, then this is over 20x plus 18, and then plus 14 is still outside. Okay, so now I'll multiply the 20 into that numerator and get 260 x plus 280 over 20 x plus 18 plus 14. No. Minus 13. Minus 13. Okay. So now that's a 14. Just ignoring the denominator for a moment. That's a 14, and we want that 14 to be over 20x plus 18. So I'm going to multiply that 14 by 20x plus 18 over 20x plus 18. Or if you like, you know, the cross multiply thing, because this is 14 over 1, and this is whatever over 20x plus 18. So that will give us a single fraction in the numerator, and then we want to do the same similar thing in the denominator. So that will be so that'll be negative 2, 3, 4 x minus 2, 5, 2, and then plus, now 14 times that, 20 times 14 will be 280x, so plus, so I'll put that in parentheses, so then that'll be plus 280x, and then 14 times 18, that should be that other number, 252, so plus 252, and then that is all over 20x plus 18, so that's the numerator. The denominator, so that would be 260 x plus 280, and now we're going to subtract, so minus, now 20x plus 18 times that, so that would be minus 260 x 13 times 18. $234. That all over 20x plus 18. All right. So now let's simplify as much as we can. So now here's negative 234x and then add 280x. So that's 46 x's. So 46 x's, and then the 252's, they just cancel, and then this is over 20x plus 18. So now the 260x minus 260x, the x's cancel, and 280 minus 234 is again a 46, but this time it's not 46x, it's just 46. 20x plus 18. So now we're dividing by a fraction, and dividing by that fraction is the same as multiplying by its reciprocal. So then, well, this will be 46x over 20x plus 18 multiplied by, now in the numerator, 20x plus 18 over 46. And, wow, the 20x plus 18's cancel, the 46's cancel, and we're just left with an x. Okay, so that means that, you know, look at how complicated that is. How complicated all that stuff is. But if you do h first and then follow it with this h inverse that we calculated, that means take this x, do all this really complicated stuff with it, and then actually that x just comes right back out. Okay, so now let's do it in the other order. Okay, so now h will go last and h inverse first. So writing that without the composition, that would be h of h inverse of x. So that would be 13 multiplied by a slot plus 14, and then divided by 20 multiplied by a slot plus 18. And then what goes in the slot is h inverse. Okay. So this is 13 multiplied by, so now we'll copy in h inverse. So that is negative 18 x plus 14 over 20 x minus 13 plus 14 over 20. Substitute in again that negative 18 x plus 14 over 20 x minus 13 plus 18 like so. So now we need to take the same strategy that we did up there. That is to say, we're going to multiply this, I'll multiply this 13 into that numerator, this 20 into that numerator, and then we need to simplify it to a single fraction. Okay, so then 13 times 18, 234. So that's negative 234 x, and then 13 times 14, 182. So 13 times 14 is 182. Then divided by 20x minus 13, and then that needs to be plus 14. So that's the numerator. The denominator, multiplying those together, so that would be negative 360 x plus 280 over 20x minus 13. So 20x minus 13, and then plus 18. Okay, so now within the numerator, I'll do the cross multiply thing to get this to be a single fraction, and do similar thing to get this one to be a single fraction. So now continuing this way, there. So that would be 14 times that would give us 280. No, first. I see. Negative 234 x plus 182, and then now subtract 280x, add 280x I need to not write over that part. So negative 234 x plus 182, and then add 280x then 13 times 14. Of course, it's going to be 182. Yeah, minus 182, and then that's over 20x minus 13. The denominator will be negative 360 x plus 280. Then we want to add to that 20x minus 13 times 18, so that'd be plus 360 x 13 times 18 is 234. So then that would be minus 234. All of that over 20x minus 13. Now I'll simplify the numerator and the denominator as much as I can. So I see negative 234x plus 280x. So 280 minus 234, that'd be 46x's. So 46 x's. And then we have positive 182 plus negative 182, so the constants cancel. This will be over 20x minus 13. That's the numerator. The denominator, well, negative 360x plus 360x, so the x's cancel. 280 plus negative 234 is 46, but no x this time, over 20x minus 13. Now, division by this fraction is the same as multiplication by reciprocal, so it'll be 46x over 20x minus 13, and now multiplied by that fraction, so multiplied by the reciprocal of that fraction, so that'll be 20x minus 13 over 46. So the 20x minus 13's cancel, the 46's cancel, and we're left with just x, and another, to me anyway, wow, for all that algebra. So we can say, therefore, H inverse really is the compositional inverse. It doesn't matter for our class, but for those of you that just like to know the names of these things, H is called a Mobius transformation. So that's M-O, and then it has two dots on top of it. Mobius. A Mobius function, that's what we'll call it.